Good morning students, welcome to the next session. I think every one of you understood what we have seen in the last class, even though now we are going to recall some basic definitions in number system. Then after that we have to enter today's session. Right, welcome back. So first, rational numbers. So rational numbers are in the form of p by q, where p and q are integers and q is not equal to 0. And some examples of rational numbers is nothing but 3 by 4, 5 by 2, minus 2 by 5, 7 by minus 3. So first two are positive rational numbers and the last two are negative rational numbers. So next, irrational numbers. So the irrational numbers are not in the form of p by q, and p and q are integers, and the q is not equal to 0. So irrational numbers cannot be written in the form of p by q with the numerator and denominator as positive integers or negative integers. The examples are pi, root 3, root 5, root 2. So everything comes under the category of irrational numbers. Now just recall whatever we have seen some problems in the last class. So the problems related to find out rational numbers between rational numbers and finding sufficient number of rational numbers between two rational numbers. That is, suppose if they are asking, that is if the question is finding the find 10 rational numbers between two numbers, means suppose after that we have only 5 rational numbers between the two, means how can you find out that sufficient number of rational numbers between two rational numbers? So the random we have seen in the last class. And the representation of irrational numbers on the number line. So how can we represent root 2, root 3, root 7, everything on the number line? So that one. And conversion of decimals into rational numbers. So how can we convert the decimals into the rational numbers? That is into the form of p by q. So this kind of everything we have seen in the last class. Now the decimal expansion. I think decimal expansion also we have seen in the last class. So what type of decimal expansion rational numbers and irrational numbers are having? So first on rational numbers. So there are two types of decimal expansions are available under rational numbers. One is terminating and another one non-terminating recurring. So these two types of rational numbers only available. That is, these two types of decimal expansion of rational numbers are available. So for example 1 by 5. So 1 by 5 is nothing but 0.2 and similarly 1 by 2 is nothing but 0.5. So likewise some rational numbers are there with the terminal decimal expansion, and non-terminating and recurring decimal expansion is nothing but 1 by 3, 1 by 7. So like this kind of rational numbers, everything comes under the second category. And one more thing is nothing but decimal expansion of irrational numbers. So the decimal expansion of irrational number is nothing but non-terminating and non-recurring. That means it cannot be end and no set of digits repeated here. So these are the definitions we have seen in the last classes. Now today we are going to see how can you find out irrational numbers between two rational numbers. So in the last class and also in our lower section, you have seen how to find out rational numbers between two rational numbers. So in that two types are available. That is, suppose the given rational numbers are having same denominator and different denominator, and we have to find out the rational numbers between two rational numbers. So that under rational numbers. Now what we have to do now? Find out irrational numbers between two rational numbers. So let us see with the example, right? So find 5 rational numbers between 5 by 3 and 4 by 7. So we are going to find out 5 irrational numbers between 5 by 3 and 4 by 7. So rational numbers means already we know that. Okay. So how can you find out rational numbers? First you have to check the denominator, they are same or not. If they are same means we can find out the numbers between the numerators. And if the denominators are different means we have to convert the denominator into same. How can you convert the denominator into same? By taking LCM. So after that we have to find out the number between the numerators. So that is a procedure to find out rational number between two rational numbers. But today we are going to see how to find out irrational numbers between two rational numbers. Listen here. So 5 by 3 and 4 by 7. So both are rational numbers. We are going to find out irrational numbers between these two. So how can you find out? The solution is, so first what we have to do is, first we have to find out the decimal expansion of the given rational number. So 5 by 3. So this is the decimal expansion of 5 by 3. That means 1 3s are 3, remainder 2 is there, and put point and 0 here. So 20 may be there. Then 6 3s are 18, again 2, again 6 3s are 18, 6 3s are 18, keep going on. So that is a decimal expansion of 5 by 3. And what about another number? 4 by 7. So that is a decimal expansion of 4 by 7. It also keep going on, not the terminated decimal expansion, it keep going on. So 0.57s are 35, so remainder 5 and 5, and here 5 7s are, again 7 7s are 49, remainder 1, and out of that 1 7, remainder 3, out of that 4 7, remainder 2. So likewise keep going on. It's not terminated. So 0.571428, and then it's keep going on 571428. So this set of numbers repeating, right? So these two rational numbers under the category of non-terminating recurring. That means, look at here non-terminating, that means keep going on, and the number 6 is repeating here. So non-terminating recurring. What about here? 0.571428. Again from the remainder, the next number 5 will come here, and then 7. That is this set of numbers repeated again. So both are what type of decimal expansion means? Non-terminating recurring, right? Now what is the question now? Now we are going to find out the irrational numbers between these two rational numbers. So how can I find out irrational numbers? So before going to find out that, what is the decimal expansion of irrational numbers? The decimal expansion of irrational number is nothing but non-terminating, non-recurring, right? So according to that, we can find out the number between these two. So non-terminating means it keep going on. It will never stop. And similarly, non-recurring means no set of numbers repeated here. Okay, that is the meaning. So according to that, we can write some numbers between 5 by 3 and 4 by 7. That is between 1.66 and 0.57. Look at the next stage. Now find the numbers between 0.57 and 1.66. Here, why we are writing the decimal expansion of both numbers means we are going to find out the next of the number from the smallest number up to the largest number. So here 1.66, here 0.57 something. So which one smallest number? So 0.57 something is the smallest number, and 1.6 is the greatest number. So we are going to find out the number start from 0.5712 or 3, 4, anything. Look at here, 0.71. Here actually 1 is there. You can start from 0.7572 onwards, right? So likewise 0.7205, 7200, 57200. So likewise. So actually one easy method is nothing but you can write first 3 letters or first 3 digits or first 2 digits, and then you can repeat the set of numbers with a different number of zeros. Look at here, 0.571 is there. We are going to find the next of the number. So 0.572 and add 1 0. Next again repeat the same 3 numbers, digits, 572. Instead of 1 0, here 2 0. Again 572, instead of 2 0, 3 0. If you want to write the next stage, 572, 4 zeros. So likewise. So in this example, anything here repeating? No, because here 5720, here 57200, here 57200, the next of the numbers 57240. So here it's keep going on, that is non-terminating, and nothing repeated here, nothing set of numbers repeated here. So non-recurring. So next one, similarly we can write 0.5730, 57300, 57300, 57340. So likewise, and you can write 574 also, then 575 also, then 576. So you can write like this. But before writing that, keep one thing in your mind. Just check whether your example which satisfies the decimal expansion of irrational number or not. That is important. Okay. Now next example. Find 5 irrational numbers between 3 by 4 and 6 by 5. That is the next example. So what is the first one? First you are going to find out the decimal expansion of both of the rational numbers. So 0.75 and 0.12, so they are the decimal expansion of these two numbers. Now we are going to find out the numbers between these two. That's it. So here minimum number 0.12 and then maximum 0.75. So you can start with 0.13 or 14, whatever it is. Okay. Look at here 0.1310, 13100, 13100. Next 13210, 13200, 13200. Next 13310 and 13300, 13300. So likewise keep going on. So if you refer these examples, all the examples will satisfy the definition of the decimal expansion of irrational number. That is, these all 5 numbers are non-terminating, non-terminating, non-recurring. Therefore, these numbers are called irrational numbers. The next one, rationalizing the denominator. So, what is a rational number? Rational number, already we know that. Okay. So we have to rationalize the denominator. For example, before rationalizing the denominator, we are going to find out one definition. That is, we are going to find out some concept. What is a concept? Means conjugate. So you should know what is conjugate. So conjugate of irrational numbers. So conjugate of irrational number. What is conjugate? Listen here. So conjugate of 1 plus root 3. So 1 plus root 3 is a rational number or not? Yes, irrational number, because 1 is rational number and root 3 irrational number. If you add anything with irrational number, the result will be irrational number. That is one main concept. So here 1 plus root 3. So conjugate of 1 plus root 3 is 1 minus root 3. And similarly, conjugate of minus 2 plus root 5 is minus 2 minus root 5. So wherever the irrational number is there, we have to write the opposite side. That is the meaning of conjugate. Next one. Conjugate of 5 minus 2 root 3 is 5 plus 2 root 3. So no need to change the sign of the rational values. That is without root number. It is need to change the sign of the root number. That is irrational numbers. Right? So that is called conjugate of irrational number. Right? So the title is nothing but rationalize the denominator. So if you want to rationalize the denominator means, so we have to we have to multiply or we have to use the conjugate of irrational number, that definition. Right? So with the help of this conjugate, we have to find out or we have to rationalize the given denominator of the irrational number. Right? So question. What is the question? Rationalize the denominator of 5 plus 1 by root 3. So how can you rationalize the denominator of this one? So let us see the next slide.